Welcome to Data Project Hub. In today's video, we will cover 30 SQL interview questions, starting with basic, then moving on to intermediate, and finally we will cover advanced SQL interview questions. So, I have divided the questions into three different sections, where in the first section we will cover 10 basic SQL interview questions, in the second section we will cover 10 intermediate SQL interview questions, and in the final section we will cover 10 advanced SQL interview questions. So after covering these 30 questions, you will learn multiple important concepts, and I think you will cover almost all the concepts you might encounter during a SQL interview. So now let us move on to the first section, which will cover top 10 basic SQL interview questions, which mainly covers the basic concepts in SQL. So let us move on to our first question. What is the difference between delete, drop, and truncate? First of all, delete command is used to remove rows from a table based on specified condition. That is, we are using delete command to remove certain records from a table. And here the table structure remains intact, which means table structure is not at all affected. The only thing which is affected by delete clause is that the records specified in the where condition will be deleted using delete clause. And the syntax for that is delete from the table name from which we are going to delete the record, and using the where condition we are going to specify the condition based on which the records are going to get deleted. An example is delete from customer table, that is table name will be customer, and where condition will specify id equal to 2 or 3, whichever id we want to delete from that particular table. So that is an example of delete clause. And coming to drop, the drop command is used to remove an entire table or a database. So drop command, we will remove the entire table without considering any specific condition. We are going to remove entire table or database. It deletes the entire table, including its structure, data, indexes, constraints, everything. And if used on a database, it removes the entire database itself. So we can use drop command to remove either a table or a database, and it will completely delete the table or database without considering any specific condition. And all the object associated with the particular table or database will also get deleted or dropped from the database when we use drop command. And the syntax for drop command is drop table, table name will be specified at the end, or we can use drop database and we will specify the database name. And coming to truncate, truncate command is used to remove all rows from a table. So truncate command is similar to delete clause. The difference is that in truncate we don't have to specify any condition. Truncate will remove entire records from a table without considering any where clause. It will remove entire records from a table. It deletes all rows from the table but retain the table structure. That is, the table will remain in the database, but the records won't be there in the database. The entire table will get blank. It is faster than delete for removing all rows from a table. It is because in the delete clause we are going to specify certain condition, and the database or the database engine will have to check the condition and then delete the record. But for truncate, we don't have a condition based on which the records are going to get deleted. So truncate will completely delete the table. Therefore, truncate will be faster than delete. Syntax for truncate is truncate table and we'll specify the table name. We don't have to specify any other condition. Only truncate table and table name specified will delete all the records from a table without considering any specific other condition. So this is the difference between delete, drop, and truncate statements. Now, when is group by used in a SQL? So group by clause is used to group rows that have same values in specified columns into summary rows, like in an aggregate function. And these are the places where we can use group by clause. The first place is in aggregation, and the second one is grouping by multiple columns. Then the third one is filtering groups with having clause. So whenever you are using a having clause, there should be a group by clause before the having clause. Then combining with joins, grouping with date or time functions. And these are two examples of applying group by clause in the query. So in the first example, we are using the department column to group the results. That is, we are counting the number of employees in each department in the first query. That is, select department, count star as employee count from employee table. And here we are using the group by clause. The group by is based on department. So in the final output, we will have a table where we have a column called as department, and the second column will be the employee count, and each department will have their corresponding employee count. And in the second example, we are using a group by clause and a having clause. Here we are displaying the departments and the corresponding average salary for which average salary is greater than 50,000. So here we have two column department, and the second is the aggregate function average salary as average salary column from employee table, and this is grouped by department column. And finally we are filtering the aggregated result based on the having clause. In the having clause we are specifying the condition, that is average of salary greater than 50,000. So our result will be having the records or the departments for which average salary is greater than 50,000. So these are the applications of group by clause. Also, make sure that whenever we answer a question, try to answer it in a structured format. So you can specify what is that particular clause and list some application of that particular clause, and then finally give some examples of that clause. It would be a good approach. Then moving on to third question. What is the difference between where clause and having clause? We already saw having clause. Now let us see what is the difference between where clause and having clause. The where clause and having clause are both used in SQL queries to filter and conditionally retrieve data. The first one is where clause. Where clause is used to filter row based on specified conditions. It is used to filter data in the context of select, update, delete, or insert. So we can use where clause in all this context. Where clause is typically placed after the from clause and before the group by or order by clause. So that is the order in which we have to specify the where clause. So this will be the basic syntax of where clause, and where clause we are using to specifically filter data based on a row by row basis. And in having clause is used to filter the result of a grouped query based on aggregate conditions. It is used in the context of select statement when using the group by clause. So whenever we have to filter some result which are aggregated based on some group by clause, we can use the having clause. Having clause is placed after the group by clause and before the order by clause. So this is an example of using having clause. Here we are counting the number of records based on the column 1, and from table we'll specify the table name, and after that we'll specify group by clause, and finally after specifying the group by clause and we have aggregated the data, now we want to filter that aggregated result. That time we will use having clause. And here we have finally specified a filtering condition based on having clause, that is having count of star greater than 10. Now moving on to fourth question. What are scalar and aggregate functions in SQL? And we have to specify examples also. Scalar functions operate on a single value and return a single value, while aggregate functions operates on a set of values and return a single value. So in both the conditions, the functions will return single values, but the way in which they operate are different. In scalar functions, they operate on single values and return single value. That is, on a row by row basis, scalar function will act. But aggregate functions operates on a set of values and return a single value. So functions like sum, average, count, minimum, and all will act on different values or different rows and will return a single value. So that is the difference between scalar and aggregate function. And these are some examples of scalar and aggregate function. uh, when we see the examples of scalar and aggregate functions itself, we will get to know what is the difference. So upper, lower, length, concat, substring, left, right, and round functions are scalar functions. So they will act on a single row and they will give a single output or a single row output. But in case of aggregate functions like sum, average, count, minimum, maximum, standard deviation, and variance, they will act on multiple rows and they will finally provide a single output. So that is the difference between scalar and aggregate function. Now, fifth question is, what does Colli's function do? So Colli's is one of the function which we use to deal with null values in SQL. Colli's function in SQL is used to return the first non-null expression among its argument. It takes multiple expressions as parameters and return the value of the first non-null expression. If all expressions are null, it returns null. And the syntax for Colli's function is Colli's, and inside parentheses we will specify expression. It can be column, it can be equations, it can be single scalar values, and we can give n number of expression in Colli's function. Expression 1, expression 2, expression n are the expressions to be evaluated. The functions return the value of first non-null expression. Consider that expression 1 is null and expression 2 is not null. In that case, Coley's function, the output will be expression 2. Consider that expression 1 is null, expression 2 is null, and until expression n minus 1 it is null. That time the output will be expression n. The function returns the value of first non-null expression. And this is an example of using Coley's function. So we are taking product name as the first column, sales quantity as the second column, and in the Coley's function we are specifying target quantity, and if target quantity is not provided or if it's null, we will specify target quantity is not specified. We will return that not specified value in that particular row as target quantity. Now moving on to sixth question. What is the difference between SQL and NoSQL database? For a SQL database, data structure is organized in tables with predefined schema. That is the structure. And in terms of scalability, it is scaled vertically by adding more resources to a single server. And query language is SQL, standardized SQL query language, and it can be MySQL, it can be PostgreSQL, it can be SQLite, and there are different variations of SQL language that can be used. And it follows acid property, that is atomicity, consistency, isolation, and durability. This itself is a big topic to understand, so I'm not going to explain each of the acid properties one by one. Actually, there are good articles where we can read about this atomicity, consistency, isolation, and durability of a database. And the use case well suited for applications with structured and complex data requirement. And examples are financial systems or e-commerce platforms. And when coming to NoSQL database itself tells that it is not only SQL database, and data structure support various data formats including JSON, XML, key value pairs, and more dynamic or non-predefined schemas. Scalability designed for horizontal scalability, allowing distributed database across multiple servers or clusters. Query language can vary depending on specific type of NoSQL databases. Consistency, it follows base properties, that is basically available, soft state, eventually consistent, prioritizing high availability and fault tolerance over strict consistency. And use case well suited for dynamic and evolving data requirement. Real-time applications, it is most commonly used. Big data scenarios and situations where flexibility and scalability are considered over predefined structures. So this is the common difference between SQL and NoSQL database. These are only few points I just wanted to list. There are more differences between SQL and NoSQL database. Now the seventh question is, what is a primary key and foreign key? So primary key is a field or a set of field in a table that uniquely identifies each record or row in that table, and it ensures that each record in the table can be uniquely identified using the value in the primary key column. And this is an example of creating a primary key column. So we are creating a table called as students, and student id we are considering as the primary key. And coming to foreign key is a column or a set of columns in a table that refers to the primary key of another table. It establishes a link between the data in two tables, creating a relationship. So foreign key actually we use in a fact table where we connect the fact and dimension table, and it will be connected based on primary key from the dimension table and foreign key in the fact table. So here is an example of creating a foreign key. So here we have created a second table, that is course table. Here for the course table, the primary key is course id, and we have another column called as course name, and we have another column which is the student id column, which is the foreign key column, which is reference to the first table which we created in the primary key example. So here we are specifying student id as the foreign key, and it references student id column from the students table. So this is how we specify foreign key constraint in a table. Now moving on to eighth question. How do you add a new record to a table? So in order to add a new record to a table, we will use the insert into statement, and the basic syntax is insert into, and next we will specify the table name, and the column names where we want to input the records. And after that, we will specify values, and inside parentheses, we will specify each value for the column which are specified in the above clause. And if you want to insert values into all columns and in the same order as they are defined in the table, you can omit the column names. And consider that our student table is having only three columns, which are student id, student name, and age. And we are going to insert data into all the three columns. That time we don't have to specify any column names in the insert into statement. We can simply specify the table name, and after that in the value clause just specify the records which we want to enter into that specific columns. Now moving on to ninth question. What is the purpose of SQL like clause? Like clause is used to search for a specified patterns in a column. It is often used along with where clause in a select statement to filter a row based on a pattern match or a wildcard match. So this is the syntax for like clause where we specify like in the where condition. That is, like is commonly used for filtering purpose, so we'll specify in the where clause condition where column name like pattern. And I have already created a video on like clause where we use different patterns to filter data. I will provide that in the description, and if you want to know more about like clause and what each patterns does, please go and watch that video. And the 10th question is, how can you retrieve unique values from a table using SQL? In order to get unique records from a table, we can use the distinct keyword. The syntax is select distinct, and we are going to specify column names from which we have to get unique records. And after that, we'll specify the table from which we have to retrieve that specific columns. Here is an example. Retrieve unique department names from the employee table. Here, select distinct, and we are specifying the column name, which is the department name from employee table. And the output of this query will be a column called as department name, where the column will be having only unique department names. That is, it will not be repeating. Also, we can use distinct keyword to retrieve unique combinations of values across columns. And here is an example of that. Retrieve unique combination of department and locations from the employee table. Here we are trying to get unique combinations of department and locations from the employee table, and the output will be, we will have a column called as department, we will have a column called as location. Individually departments and location will be repeating in the specific output, but as a combination, department location combinations will be unique for that particular output or this query. Now that we have completed the top 10 basic SQL interview questions, let us move on to the second section, which will deal with top 10 intermediate SQL interview questions. So let us start with the first intermediate SQL interview question. The first question is, what are constraints? Explain different constraints. This is a very commonly asked question because the understanding of constraints will let us maintain the accuracy, reliability, and integrity of our dataset and database. So this is very commonly asked, and it is a very important question during SQL interviews. So constraints are basically used to specify rules for the data in a table, and this ensures accuracy, reliability, and integrity of the dataset in the table. And following are the constraints which are commonly used in SQL. So these are the commonly used constraints which we see in our day-to-day activities as a data analyst or a SQL developer, or even a Tableau or a Power BI developer can come across these constraints. So the first one is not null constraint. So not null constraint will ensure that the column will not be having any null value. So it ensures that a column cannot have a null value. The second one is unique constraint. Unique constraint ensures that all values in a column are different. So the column cannot contain any duplicate value. All the values in the column will be unique. And also one thing to note here is the column on which unique constraint is specified can have null values. So there is an exception for null value. A column for which unique constraint is specified can have null values, but the values cannot duplicate other than null. So that is unique constraint. So the third constraint is primary key constraint. So a combination of not null and unique constraint. So primary key constraint can be considered as a combination of not null constraint and unique constraint, because for primary key column or a column on which primary key constraint is specified, all the values will be unique, and also the column should not contain any null value. So it is a combination of unique constraint and not null constraint. And coming down, we have the foreign key constraint. So foreign key constraint prevent actions that would destroy link between tables. So normally we use foreign key constraint to establish relationship between fact tables and dimension tables. So in that case, whenever a record in the dimension table is deleted or get affected, the same thing will get reflected in the fact table. So in order to establish that kind of a relationship, we use foreign key constraint. And the next constraint is check constraint. Check constraint ensures that value in a column satisfies a specific condition. So if I come down, I have noted an example here. So we can see that here there is a column called as age, and the data type is integer data type. And I have specified one check constraint here, that is age should be greater than 18. So whenever a person is entering data or inserting record into the persons table, there is a condition, that is age of that particular person should be greater than 18. And whenever that condition is not satisfied, the record will not be accepted and we will get an error message. So that is the purpose of check constraint. And coming down, we have a default constraint. So sets a default value for a column if no value is specified. So as the description suggests, default constraint will specify a default value for a column if there are no values specified. And in the example here, we can see that we have a column called as city. The data type is variable character, and whenever a person is not entering any value into the city column or city record, the value will be New York. So this will be the default value for the city column. And below we have a create index constraint, and it is used to create and retrieve data from the database very quickly. So the purpose of index is to actually improve the performance of our database or the queries which we are running on a particular table or a database. And coming down, we have an example in which I have used almost all the constraints I have explained. So here I am creating a table called as persons table, and we have id column where I have specified the unique constraint, and one more constraint I have specified here, that is not null. And the last name constraint, I have specified another constraint called as, sorry, the last name column I have specified another constraint called as not null. Coming down, we have first name, age, city and spouse. Age I have explained when I went through the check constraint, and city we have the default constraint that was also explained. Then coming down, we have the spouse id, which is the foreign key constraint or the foreign key specified on the table. So here what happens is, we have a separate table called as spouse table, and the primary key for that spouse table is id in that particular table. So we are actually creating a relationship between spouse id column in the persons table and id column from the spouse table. So whenever there is a change in record that is happening in the spouse table, the same thing will get reflected in the persons table for the spouse id column. So we are creating a foreign key relationship between spouse id and id column from the spouse table. Now let us move on to our second question. How many primary key and unique key can be there in a table? A table can have only one primary key, but it can have many unique keys. So previously we have gone through primary key constraint and unique key constraint. So the same definition applies here. So what is a primary key? A primary key is a column or a set of columns that uniquely identifies each row in a table. Primary key constraint ensures that the value in the specified columns are unique and not null. That is a combination of unique constraint and not null constraint. And when coming to unique key is a constraint that ensures the value in a column or a set of columns are unique across the entire table. So the value will not be repeating except null. So here that is specified. Unique key can be null unless the columns are also marked as not null. So what happens is, here id int not null unique. So what happens is, here this will actually act as a primary key. So once we remove this not null, now on this column only unique constraint is specified. That time the column can contain null values also. Otherwise, with the not null constraint specified, the column cannot contain null values. Otherwise, with only unique constraint specified on a column, that can contain null values also. That is the difference between primary key and unique key. So once more I will tell. So primary key is a combination of unique key constraint plus not null constraint. And unique is simply tells that a column can only have unique values except for null values. That is, it can also contain null values. So that is the difference between primary key and unique key. Now moving on to third question. What are joins in SQL and type of joins? So joins are used to combine rows from two or more tables based on a related column between them. So it need not be a single column. So it can be multiple columns also. That is, a join condition can be specified on different columns. Here in the definition, it is specified that combine rows from two or more tables based on a related column. So it is not on a, it can be based on multiple columns also. And these are the different kinds of joins in SQL. So there are inner joins, left join, right join, full outer join, cross join, self join with exclusion, and non-equi joins. And I have a screenshot for the joins. I will show that. These are the joins that we will come across in SQL. So the first one is a left join. So it will take all the records from table A and common records from table A and table B. So that is a left join. And the second one is an inner join. That is, it take all the records common to both table A and table B. So that is the inner join. And the third one is a right join. It takes all the records from table B and common records from table A and table B. And coming down, we have a left join with exclusion. So what happened here is, it will take the records which is only available in table A, and the common records will not be considered. Common records and the records which are only available in table B will not be considered in the output. So that is the left join with exclusion. The next join is full outer join. So in this join, everything is joined between the two tables. That is, every record from table A and every record from table B will be there in the output. And the next one is full outer join with exclusion. So here the common records, actually this is kind of opposite to inner join. So here the records which are common to both the tables will not be there in the output, except that all the records will be there in the output. That is, the records which are only available in table A and the records which are only available in table B will be available in the output. And here also the tricky part is the where condition. That is, here we are specifying A dot key is null or B dot key is null. So this where condition converts the normal join into join with exclusion. And the final join in this diagram is right join with exclusion. So this is kind of opposite to left join with exclusion, where right joining is happening, but the common records between both table A and B is not available in the output. So this is right join with exclusion. Three more joins which I have specified. Those are cross join, self join, and non-equi joins. So in case of non-equi joins, the join condition will be having something other than the equal sign. So it can be greater than, less than, not equal to. So those are joins where the equal to sign will be replaced with some non-equi conditions. So that is non-equi join. And cross join is, we are joining every record of a table with every other records of the another table. So that is kind of a Cartesian product. So consider that we have 5 records in table A and we have 10 records in table B. So all the 5 records from table A will be joined with all the 10 records in table B happening. In self join, we are joining the same table with itself. So self join actually we apply in cases where we are trying to find manager employee hierarchy kind of questions. We use concept like self join. So that is where this join comes into play. Now moving on to next question, which is, what is the difference between union and union or? Union is basically used to combine the result set of two or more select statement. So the difference between join and union is that here the appending of data is happening. So we are combining result from different select statement, and the number of rows are actually getting increased, or it is kind of appending data happening in the union clause. And now what is the difference between union and union all? In union, duplicate rows are eliminated, but in union all rows are kept. That is, whenever we are doing a union clause, the duplicate records will be eliminated from the record. Let us take this example. So here what I'm trying to do is, I'm selecting all the students name from class A and I'm creating a union with all the students name from class B. Now consider that we have same student name repeating in class A and class B. So for union, in the final output, there won't be any duplicate student name. So every student name will be unique. Even if there are duplicate student name, the union clause will handle that, and in our output, we will only have student name which are unique. But in case of union or that uniqueness will not be considered, and instead of unique student name, all the records or all the student name from class A will append with all the student names from class B. And also, if we are taking performance as a constraint, it is not recommended to use union, and it is recommended to use union all, because in case of union all, the SQL engine does not have to compare the result and find duplicates. So union all will perform better compared to union. So that is the difference between union and union all. Now next question is, what is the order of execution in SQL code? This is a very important question because getting to know the order of execution of SQL code will help us write better SQL code compared to the other way around. So the order in which SQL will execute is, the from clause will execute first, then where clause will happen, then group by, followed by having clause, then select clause, order by, and finally top. So this is the basic order of execution in SQL code. And I have an example to explain this. So here what we are trying to achieve is, we are getting the average salary for each department where salary should be greater than 50,000 and employee count per department should be greater than 3. So here what happens is, so from employee table, that is happening first. We are taking all the records from employee table, and then a where condition is applied. So the employees or the records for which salary is greater than 50,000 will only be taken to the next part of query. And then a group by clause is happening based on the department name, because there is an aggregate function here in the select clause. Also we have a having clause, so we have a group by based on department name. That is the next thing in the order of execution. Then coming down, we have a having clause based on which the aggregated data is filtered. That is, the department name for which employee count is greater than 3 only will considered in our output. So having count of employee id greater than 3, and now the select clause will happen. That is, select department name average of salary, and we are giving a name as average salary. So that part will complete, and now we have to order the result. That is, order by average salary. So now we have completed this select clause, or select part is completed, so that we can use this alias name in the order by query. So as you can see, I don't have to write average salary here. I can directly use the average underscore salary name, because before order by clause, select clause has completed running. So now we are ordering the result based on average salary in descending order. And now if we want only the top one department based on average salary, what we can do is, after not here, sorry, here in the select clause, we can write a top one department name average salary as average salary. Now this query will return only the department with the maximum average salary for the following conditions specified in the query. So this is the order of execution for SQL code. Now moving on to next question. How many joins are required to join 8 tables? So I have seen people asking these questions very commonly. The basic or the simple equation that can be used to answer this question is n minus 1, where n is the number of tables. So here we have 8 tables or 8 input tables. So the answer will be 8 minus 1, that is 7. So 7 joins should be used to join 8 tables. But initially when we hear this question, our first answer might be 4, because there are 8 tables and we are joining every table with every other table. So sometimes the initial answer can be 4, but just try writing a simple example like this one. So consider that we have 8 tables, and now we want to join these 8 tables. So what happens is, we join table 1 with table 2, and we write the on clause where we specify the join condition. Similarly for table 2 and table 3, we are writing another join condition, and next join condition, then after table 4 again one join condition, and that will continue after 5, 6, and finally after 7 also. Now simply count the number of joins we have used. That is 1, 2, 3, 4, 5, 6, 7. So here we have 8 tables, so we have used 7 joins. So in order to join 8 tables, we will have to use 7 joins. Similarly, Consider that we have 100 tables. How many joins should be used to join the join all those 100 tables? The answer should be 100 minus 1, that is 99. Moving on to next question. So what is the difference between a candidate key, a primary key, and a unique key? So all the three terms, that is candidate key, primary key, and unique key, are related concepts but with different roles. So these are very similar but has got only minor differences. The candidate key are set of columns that could serve as the primary key. Primary key is the chosen candidate key for unique identification, and unique key enforce uniqueness but may not be primary identifier for the record and can also have null values. So there can be multiple candidate key for a table. From that candidate keys, we will take only one key as the primary key, and there can be columns where the unique constraint is also specified. So that column will only have unique values. But the thing is, since the column, since for the column only unique constraint is specified, it can also have null values. So we cannot take that column as a primary key column or a candidate key. So that is the basic difference between candidate key, primary key, and unique key. Moving down, I have mentioned three examples for the same. Here in the first example of employee ID and social security number acting as the candidate key. And now when we come down, we can see that I have created a table called as employees table. And here an employee can have a unique employee ID and it cannot be null. A employee will definitely have an employee ID. Also, he will definitely have a social security number and it can also not be null. So these are two candidate keys which can act as primary key. So the choice of primary key depends upon the database developer or depending upon the requirement of project. So any among employee ID or social security number can act as the primary key for this table. And coming down, we have the employee ID chosen as the primary key for the table. So out of social security number and employee ID, I have taken employee ID as the primary key column for the employees table. And coming down, here is another column which is added, that is the email column, on which the unique constraint is specified. So here the email can sometimes have null values. It can be because of some issues with the database. So we cannot consider email as a primary key or a candidate key. Instead, we will specify unique constraint on the email column. So that is the basic difference between candidate key, primary key, and unique key. Coming down, the next question is, explain the purpose of SQL case statement with example. Conditional expression that allows you to perform conditional logic within a query. So that is the simple explanation of case statement. So case statement helps us perform conditional logics within a query. So the basic syntax for case statement is, this is the basic syntax. So we'll start with a case, and when we will specify the condition, and then based upon the condition, the result which is required is specified here. Similarly, we will write n number of when and then conditions, and finally, if any of the condition is not satisfied, using the else statement, we will provide a default result, and finally, we will end the case statement. So this is the basic syntax of case statement. Also, I have mentioned one example here, that is, here we are trying to identify whether an employee is a junior, mid-level, or senior level based on their years of experience. So here we are taking employee ID, first name, last name, and years of experience from the employee table directly. And also one more column is added, that is the experience category. And here we are using the case statement, that is case when years of experience less than 3, then that employee is considered as junior. Or when years of experience is greater than or equal to 3 and years of experience less than or equal to 7, then that employee is considered as mid-level employee. And when years of experience is greater than 7, that employee is considered as a senior employee. And if something is not specified, we will provide the text as not specified, that is default category if year of experience is null or unexpected value. That is the use of case statement in a query. Moving on to our next question. The next question is, what is a subquery and where can subquery be used? A subquery is also called as nested query or inner query. So the question can also be like, what is a nested query or inner query? So don't get confused. A subquery, nested query, or an inner query is the same thing. A query that is embedded within another query is called a subquery. So the query in which it is embedded is called the outer query, enclosed inside parenthesis and can be used in various parts of SQL statement. So subquery will be enclosed in parenthesis and it can be used along with select statement, from clause, where clause and having clause. And here we have two examples in which we are using subquery in where clause and subquery in having clause. So in the first example, we are trying to retrieve employees belonging to engineering department. So in our query, I'm using two tables. The first table is employees table and the second table is departments table. So in our employee table, we don't have a column called as department name. So what we are trying to achieve here is we are trying to get the department ID from the departments table and trying to equate it with the department ID column from the employees table. So we are selecting all the records from employee table where department ID equal to, now we are using a subquery. And inside the parenthesis, we are specifying select department ID from departments where department name equal to engineering. So this query will fetch all the department ID corresponding to engineering department name and only the records specified with with those department IDs will be provided in our final output. And coming down, we have a having clause in which we are using subquery. So here we are trying to find employees whose average salary is greater than a certain threshold. Here the threshold is the total average. So we are selecting employee ID, first name, last name, and then we are using an aggregate function which is the average salary and giving an alias name as average salary from employees table and group by employee ID, first name, last name, all the three column names which we are using in our input. And this is taken from employee table, and after the group by clause we are having a having clause. So here the filtering based on having clause is happening, having average salary greater than the total average. So inside parenthesis we are writing the subquery, this is the subquery. So we are taking select average from employees, sorry, average salary from employees. So this query will return the overall average salary from employees table, and using a subquery in from clause is relatively simple compared to using the subquery in having clause or where clause. Now the next question is, what is a stored procedure and when would you use one? A stored procedure is a pre-compiled collection of one or more SQL statement, and it is created and stored in a database management system and can be executed by applications or stored procedures. So we may use stored procedure to trigger different actions in our database. So we can connect these stored procedures with applications like Tableau, Power BI, or other BI applications, or even mobile apps. We can connect these stored procedures. So based on some actions which happen on those applications, some actions will be triggered in our database based on the definition of our stored procedures. So that is one use of stored procedure. And we have an example of stored procedure here created. So what I'm trying to achieve here is trying to get all the records of employee from the employee table where employee ID is specified within the stored procedure. That is, whenever we are trying to execute the stored procedure, I'm providing the employee ID as a separate input. So this is the basic syntax. So create stored procedure, that is create procedure, and this is the procedure name, that is get employee id by get employee by id, and this is the input parameter, that is at employee id, which is an integer. And now we are beginning the stored procedure definition, that is begin select star from employees where employee id equal to at employee id. So whatever we are providing as an input to the input parameter at employee id will be provided in this where clause, and we will get an output based on that. So whenever we are trying to execute this stored procedure, that is exec execute get employees by id at employee id equal to 101, we will get an output where the records for employee id 101 will be fetched and returned. And these are some other cases where we use store the procedure, that is in order to run complex queries, and if there are like multiple custom aggregations and it is hard to execute all this in the backend of some BI tool, we may use some kind of stored procedures. And in order to run scheduled jobs and data pipelines, and in order to run data updates in our database, we may use stored procedures. And moving on to our final question, that is, what is the purpose of SQL check constraint? Check constraint is used to specify a condition that must be true for each row in a table. ensures that the value in a specified column or combination of columns meet a certain condition, and any attempt to insert or update data that violate this condition will result in an error. So the common purpose or the purpose of SQL check constraint is to maintain the data integrity within the database. And here is an example of using check constraint on a single column and check constraint on multiple column. So for this persons table, we are providing the check constraint for age column. So here we are checking the age is greater than or equal to 18. So that constraint is specified on age column. So the input should only contain age that is greater than or equal to 18. And if we are providing an input for the age column which is less than 18, it will throw us an error. So that is how we apply check constraint on a single column. And coming down, here is an example of check constraint on multiple column. So here we have different columns called as ID, last name, first name, age and city. And on this age column and city column, we have a constraint created called as check underscore person. And we are checking if the age is greater than or equal to 18 and city equal to Texas. So whenever we are trying to insert record into this person's table, age should be greater than or equal to 18 and city should only have one value, that is Texas. Other than that, it will give us an error. So this is how we can specify constraint on multiple columns. We can add more columns if required, but here we are specifying it on two columns, which are age and city column. Now we have completed top 10 basic SQL interview questions and 10 intermediate SQL interview questions. Now let us move on to 10 advanced SQL interview questions that you will definitely encounter in SQL interviews or data related roles. So our first question is, what are window functions or analytical functions? Functions that perform calculations across a specified range of rows related to the current row within the result set. And it is particularly useful for performing calculations that involve aggregations or comparison with the neighboring rows. So that functions are basically called as window functions or analytical functions. And these are the commonly used window functions. The first one is row number, which assigns a unique sequential integer to each row within a partition of a result set. So window function will be acting with respect to a partition or a window with respect to the input data. And the second window function is rank, which assigns a unique rank to each distinct row within a partition of result set. And thence rank is similar to rank but assigns consecutive integers to tied rows instead of skipping rank. So in case of rank function, it will be skipping some rank when the values are same, but in case of dense rank, even if the values are similar, rank will not be skipped. We will see detailed example of rank and dense rank function in an upcoming question. The next function is entile function, and which will divide the result set into n equally sized buckets, assigning a bucket number to each row. And the next is sum, average, minimum, maximum, which are the aggregate functions and which can be used as window functions. Next one is lead and lag function, which access data from subsequent or previous row in the result set. And coming down, we have an example for window function where we are using the sum window function or sum aggregate function as a window function to calculate the running sum. Here we are selecting order ID, order date and total amount from the orders table. And in this expression, we are calculating the running sum or the cumulative total using the sum function, which is the aggregate function, but here we are taking the sum function as a window function. So we are calculating sum of total amount over and using an order by clause within the over clause based on order date and calculating the running sum. Similarly, window functions are having lot of application in our day-to-day analysis. Now moving on to our second question. What is the difference between rank and dense rank? Rank and dense rank both are window functions which assigns a rank to each row based on the value in one or more columns. Rank may have gap in the rank sequence when there is a tied value. In case of dense rank ensures a continuous sequence of rank number without any gap. So now we will see an example, then it will be pretty clear. So here is a marks column which consists of 10, 20, 30, 30, which is repeating, 40, then 50 is repeating two times, and 60. Now, if we are ranking the column marks based on rank, the rank will be 1, 2, 3, 3, which is corresponding to 30 and 30. Then we are skipping the rank 4. Then for 40, we are giving the rank 5. Then for 50, we are giving rank 6. Then for the next 50 also, we are giving rank 6. And since we have given the same rank to two of the marks, we are skipping the rank 7 and we are giving rank 8 to mark 60. And when we come to dense rank, here rank 1, 2, 3, 3 is given to marks 30, then 4 is given to 50, sorry, 4 is given to 40, then rank 5 is given to 50, and again 5 is given to 50, and 6 is given to 60. And now when we compare the result of rank and dense rank, we can see that in case of rank, the numbers are skipped. When there are equal marks, we are skipping the ranks. But in case of dense rank, even when there are equal ranks and for multiple rows or multiple records we are giving the same rank, we are not skipping any record. So in case of dense rank, the rank will be continuous. And in case of rank, there will be some breaks in between the ranks. So that is the basic difference between rank and dense rank. The next question is, what is view and how it is different from a table? View is a virtual table that is based on the result set of a query. It does not physically store the data itself but provide a way to represent the result of a query as if it were a table. So this is the most important point, that is, it does not physically store data within the table or within the database. Key difference between view and table is, in case of storage, table physically store data on disk, while a view does not store any data itself. It is simply actually a query. And in case of data modification, directly insert, update or delete records in a table. Ability to modify data through a view depend on the complexity of underlying query and the presence of certain conditions. That is a bit advanced topic. Normally, we don't directly insert, update or delete records into a view query. We can insert data through a single table view if we have insert privilege on the view. So this is with respect to how we can insert data into a particular view. To do this, the defining select schema can select from only one table. So it is given that if the view is with respect to only one table, we can directly insert records into the view. And it cannot contain any of the following component, that is, if the view query consists of keywords like distinct, group by, or some kind of derived values or aggregate values, we cannot insert records directly into that particular view. And in case of structure, tables have a fixed structure. View derive their structure from select query which define them. Index and keys. Tables can have indexes, primary key, foreign key, and other constraints. Views do not have their own index or key. Instead, they rely on index and key of the underlying table. And coming to security and abstraction, view can be used to restrict access to certain columns or rows in the underlying table. They provide a layer of abstraction. That is, consider that we need to provide only certain columns from a table to our end user. In that case, we can use a view because other columns might contain some sensitive information which should not be present to the user. So in that case, we can use view so that we can create a layer of security or a layer of abstraction. And that gives us a additional layer of security. And for that purpose also, we can use view. Our next question is, what is CTE and where to use CTE? CT is temporary result set in a select, insert, update or delete statement that is referenced within the scope of a single SQL statement. CT are defined using the with clause. It makes complex queries more readable and easier to manage. And this is the basic syntax for common table expression. So we are using a with clause and this is the name of the common table expression, and these are the columns which we are taking from the CTE. Then inside the definition or the parenthesis within the with clause, we are providing the
CTE query definition. This is the definition which tells us to select column 1 and 2 from the input table, that is sum table, and we can give some where condition in the parenthesis, within the parenthesis. And after this we can write any main query using the CTE. So this select star from CTE name is based on the CTE which we created using the with clause in the previous statement. Now this is particularly useful in various scenarios to improve readability, maintainability, and organization of complex queries. Also, code reusability and recursive CTE, we may use common table expression. So these are the common use cases of common table expression. Now moving on to our next question, which is how do you enforce uniqueness in a column? So this question is with respect to constraints. Enforce uniqueness in a column by using the unique constraint. So we can use unique constraint to enforce uniqueness in a column. The unique constraint ensures that all values in a column or a combination of columns are unique across the entire table. And this is how we can create a unique constraint with respect to a column. So here is the basic syntax. So here I am creating a table. This is the table name, this is the column name, first column name and corresponding data type. Similarly I am creating n number of columns, and here is the unique constraint enforced column, which is unique column name. This is the data type, and then after that we are going to provide the unique key, unique constraint. So once we provide this unique constraint here, this unique column name can only accept values which are unique. Also, once a table is created, we can add a unique constraint to an existing table using the following syntax, that is alter table. This is the table name to which we are going to add a unique constraint. Then add constraint, this is the constraint name, so it can be whatever name that we like. Then unique, which is the constraint, and here is the column name to which we are going to apply that constraint. And next is add unique constraint to a combination of column. That is, we can consider different columns as a single combination, and we can enforce unique constraint to that combination of column using the below syntax. Here we are altering the table name, we are providing the table name, then add constraint, unique constraint name, it can be whatever constraint name. Then we are providing the constraint which is unique constraint, and inside parenthesis we have to provide the different column names based on which we are going to consider that particular combination as unique. So this is how we can apply unique constraint to a combination of columns. Now moving on to our next question, where to apply cross join. Cross join is also known as Cartesian join. So people can also ask what is a Cartesian join, and it is used to combine each row from one table with every row of the another table. So it can be used to create combination, that is the first use case, and it can be used to create Cartesian product. So here in this example we are creating combinations based on table colors and sizes. So select star from colors table which consists of different colors, and a second table which is called as size table which consists of different size. So now here we are creating different color and size combination using the cross join. And here in the second example, we are creating Cartesian product. That is, we have a number set table, which is our first table, and the second table is number set two, which is our second table, which consists of different numbers. And now we here want to create a new table such that every numbers in the number set table one is combined with every other number in the number set 2 table. In that case, we will use cross join. So these are the two examples which you can explain if you are asked some examples for cross join. So the first one is generating combination and the second one is creating Cartesian products. And now the next question is how do you optimize a SQL query for better performance? And what are the four techniques? There are many techniques to optimize SQL query. Mostly it's based on what is the underlying query and what is our final goal, but these are very commonly used, and it can be applied to most of our use cases. So the four methods are we can use indexes. Then the second one is limit the result set. So that is, instead of using select star, we may use select only the column names which are required in our final output. Then the next one is avoid select distinct. So instead of using select distinct, we may use group by clause to group the data or identify unique records from the table. And the final method is optimize join operations. So we may use appropriate joins and always try to join with bigger tables. So if we are writing a left join, consider that the biggest table or the parent table as the leftmost table. In that case also we can optimize our query. Next question is, what is the purpose of SQL pivot and unpivot operator? It is used for transforming data between a relational format and a cross tabular format. And the second one is useful to rotate rows in columns, that is pivoting, or revert, that is columns back to rows using unpivoting. And this is two examples of pivoting and unpivoting syntax. In this pivot example, as our final output, we will have product as the first column, then January, February, March, April, May, and June as our subsequent columns. That is, we have converted this month column into different rows, sorry, different columns. And inside, we will have the or the in as the combination of product and months, we will have values within the tables. That is sum of sales. And coming down, we have an example for unpivot function where we are doing the exact opposite to what we saw in our previous pivot example. So here we are converting this month back into raw data. So in the first column, we will have product name. In the second column, we will have the column name as month, and the column values will be January, February, March, April, May, and June. And as the third column, we will have sales column. So our final output will have only three columns in this unpivot example. And when we come to our pivot example, in our final output we will have Jan, February, March, April, May, June, this six column plus one column which is the product column. That is seven columns we will have in our pivoted output. So that is the difference between pivot and unpivot. The next question is, how do you handle null values in SQL queries? The first method is using is null or is not null. Example is, we are selecting column 1 and column 2 from table 1 where column 1 is null. So whenever the column 1 is having some null values, only that particular records will be selected. In case we need records for which column 1 is not null, that case we will modify the query such that here column 1 is not null. So this is one method of filtering records using is null and is not null. Second one is using collies function. Select column 1, comma, collies. Inside parenthesis, we are specifying the expression or the column, comma, the default value. So whenever the column 2 is having some null value, the default value will be substituted instead of the column 2 value. That is the use of collies function. And the rest of the query remains same. That is as column 2, which is the alias name from table name. And the third function is null. This is similar to collies function, but collies can have many number of arguments, but in case of is null function, it can only have two arguments. So is null column 2, which is the column name or the expression, and the second expression is the default value. So if column 2 is having null value, that time default value will be substituted instead of column 2 value. And coming to our next statement, which is the case statement. Using case statement also we can deal null values. So here we are selecting column 1, then we are writing the case statement, that is case when column 2 is null, then we substitute the default value, else the value will be from the column 2 only. And then we are ending the case statement and giving an alias name as column 2 from the table name. And the final function is null if. Select column 1, comma, null if, that is if column 2 is having some specific value, that is the condition. So if column 2 value and condition is matching, that time it will be substituted by null. So this is very commonly used in case of division. So whenever we are dividing some number, like 1 by 0, that time it will become infinity. In that case, what we are doing is we will substitute this 0 with the null if function, null if 0 comma 0. In this case, this 0 will be substituted by null, that is 1 by null will become null itself, so that there is no infinity in our final output. So null if is very commonly used to deal with 1 by 0 error. Now we are moving on to the next question, which is our final question. That is, what is the purpose of SQL lead and lag window function? Lead and lag window function are used to access subsequent and preceding rows in the result set within the same query result. This is part of window function category. The lead function syntax is like lead, open and close parenthesis. We will specify the expression, which is the column name in most of our cases, and this is the offset value, that is the number of columns above or below to which we have to look. Then this is the default value. If there are no values with respect to that particular offset, we can take the default value as our final output. And then we have the overclose, and inside parenthesis we specify the partition by and the partition column and order by and the order by column, that is the column based on which we have to order our result. And similarly we have the lag function, which has the exact same syntax. Then this is an example of using lead function. So here we are calculating the percentage change, query using lead to calculate percentage change. So here we are selecting product id, month and sales amount. Now we are using a lead function on the sales amount column, and we are considering this column as the next month sales. And then we are calculating the percentage change, that is this equation corresponds to next month sales subtracted by sales amount, that is the sales of the previous month divided by sales of the previous month, which is then multiplied by 100, which gives us the percentage change. And this is from sales table and order by product id and month id. And this query will gives us the insight into how sales amount change from one month to next month for each products.
Now that we have completed 30 SQL interview questions, I think you have got a good understanding of what are the different concepts that you will come across in a SQL interview. Hope you like this video. Thanks for watching and subscribe for more. Thank you.